Very good morning, students. Today I am going to see how to convert transfer function to state model. Okay. So here we have in the transfer function 10 divided by s cube plus 4s square plus 2s plus 1. This I am going to convert into state model. So what is the state model? State model having two equations. One is a state equation that can be represented by x star equal to ax plus b. Another one is the output equation y equal to cx plus d. Okay. So now this D matrix suppose equal to 0. Only we are going to obtain A matrix, B matrix and C matrix. Then we can find state equation as well as output equation. So we'll start with from the transfer function. Here having y of s by u of s. Here the y represents the output and the u of s represents the input. Okay. Just cross multiply. Okay. Y of s into s cube plus 4s square plus 2s plus 1 equal to 10 into u of s. Okay. Just multiply y of s into s cube plus 4s square into y of s plus 2s into y of s plus y of s equal to 10 into u of s. So we got the equation all in the s domain. If you want to convert it into state model, first you have to know what is the inverse Laplace transform. So what is the Laplace transform for this differential term? So Laplace transform of d cube y by dt cube, nothing but s cube into y of s. Similarly, Laplace transform d square by dt square, nothing but s square into y of s. Laplace transform dy by dt is nothing but s into y of s. Similarly, Laplace transform of y of t is y of s. Okay. So if you want to convert s domain to y of time domain, take inverse Laplace transform. So for this equation, take inverse Laplace transform. So what is the y of s in s cube? So s cube y of s, if you convert, it will convert into d cube y by dt cube. Okay. Similarly, 4 is a constant. S square y of s, if you convert 4 into d square y by dt square plus 2 is a constant. S into y of s can be converted into dy by dt plus y of s nothing but y of t equal to u of s normally converted into u of t. So 10 into u of t. Okay. So now we got s domain to time domain. Now we have to convert it into state model. That is, one is a state equation, another one is a output equation. So how can you obtain this state equation? Okay. So for this we have to know what are the state variable for this equation, time equation. So first we have to cross multiply and got the equation s domain. Convert this equation into time domain using inverse Laplace transform. Okay. Now we have to form the state variable. So how can you form the state variable? So here see the highest degree in the differential equation. So highest degree is 3. So we having 3 state variables for this equation. We having 3 state variables. How can you form the state variable? The state variable formed from the lowest order. That is the first one. We can take x1 as one of the state variable. x1 equal to y of t. Okay. Second state variable x2 can be written as dy by dt. Okay. And third state variable x3 is nothing but d square y by dt square. So we having 3 state variable x1, x2 and x3. So from this state variable we have to form the x star. X star represent derivative. Okay. So we having 3 state variable means we have to form x1 dot, x2 dot, x3 dot. So we have to form x1 dot and see what is the corresponding derivative. Okay. So start from the x1 dot. So x1 dot is nothing but derivative of y of t. What is the derivative? dy by dt. Okay. So the dy by dt can be written as x2. Okay. So nothing but x1 dot is dy by dt, nothing but x2. So this makes this equation 3. Okay. Similarly, take derivative of x2 dot. So x2 dot equal to x2 dot nothing but what? D square by dt square. One derivative of dy by dt, d square by dt square, nothing but dy by dt nothing but x3. So nothing but this is x3. Okay. Next one, third derivative of x3. Okay, x3 is nothing but x3 dot. So x3 dot we have to represent from the equation 2. Okay, so the derivative of x2 dot, x3 dot can be written from the equation 2. So make this equation for x3 dot. So dq by dt cube nothing but x3 dot. Okay, so x3 dot nothing but derivative of d square by dt square. Derivative of d square by dt square nothing but d cube by dt cube, that is x3 dot, plus 4 into d square by dt square. D square by dt square nothing but x3 plus 2 into dy by dt. Dy by dt nothing but x2. 2 into x2 plus y of t. Y of t nothing but x1. So x1 equal to 10 into u. 10 into u. U is nothing but input. Okay, so u can be represented as it is. From this written x3 dot equal to 10u minus of x1 minus of 2 into x2 minus of 4 into x3. So this is the x3 dot equation. Make this equation 5. So we got x1 dot, x2 dot, x3 dot. Okay. Now we can form the state equation. So we can form the state equation. Okay. X dot equal to ax plus b. So x dot equal to ax plus bu. Okay. X dot can be written as x1 dot, x2 dot, x3 dot. Okay, x1 dot, x2 dot, x3 dot. Okay, so here we having three variables. So A matrix can be 3 cross 3. Since we have this 3 state variable x1, x2, and x3. Okay, plus the B matrix is 3 cross 1 into U matrix. Okay, so what is the A matrix? See the first equation. X1 dot will have only the variable x2. So x1 variable is 0. X2 quotient is 1, x3 quotient is 0. There is no u term in the x1 dot. Okay, so u also 0. So let's see the x2 dot. X2 dot will only having x3. So make x1, x2 0 and make x3 as 1. There is no u term also. Make this as a 0. Okay, x3 dot equal to minus of x1. Minus of x1 is minus 1 and x2 quotient is minus 2 and x3 quotient is minus 4 and u quotient is 10. So we got the state equation x dot equal to ax plus bu and a is nothing but a quotient of x1, x2, x3 from the corresponding x1 dot, x2 dot and x3 dot. Okay, if there is any u quotient is present means you can put the corresponding B matrix. So this is a A matrix and this is a B matrix. Okay. Similarly, how can you find the output equation? How can you find the output equation? So how can you find the output equation? So see here, y equal to cx plus d. D is 0. Leave it out. How can you find cx? Okay. See the equation. See the state variables. What you have found. What is the y in terms of y? Is there any equation present in the state variable? We having y equal to x1 equal to y of t. Okay, so this y of t can be considered as the output equation. So y of t is x1. Okay, so y equal to cx. Okay, so c can be represented as 1 cross 3 matrix x1, x2, x3. Okay. So see, what is the coefficient present y equal to? Only we having x1. So only we have the x1 coefficient. The other coefficient makes a 0. So the combination of state equation as well as output equation forms the state model. So equation number is 6 and this is 7 and 6 and 7 forms the state model. Combination of state equation and the output equation forms the state model. Okay students, I think this is understand for it how to convert state model to transfer function to state model. Okay, so we'll see more problem in the next class. Thank you. morning students. Today I am going to see how to obtain the state model for the given differential equation. Okay. So this is a question: obtain the state model of system whose characterized by differential equation d cube by dt cube plus 6 into d square by dt square plus 11 into du by dt plus 6y plus u equals 0. So they given the differential equation. How to convert it into state model? So first of all, what is the state model? So state model having two equations. One is the state equation, other one is the output equation. State equation have represented by x dot equal to ax plus du, and output equation represented by y equal to cx plus du. So the D matrix suppose 0. So only we are going to find the y equal to cx. Okay. So we are going to obtain the matrix for A, B, and C matrix. So first of all, start with this not how to obtain the state equation, then you can follow by the output equation. So from the differential equation, the differential equation in the time domain, okay, that is the d cube by dt cube plus d square by 6 into d square by dt square plus 11 into du by dt plus 6y plus y plus u equal to 0. Okay. So how can you convert into, how can you form the state variable? So if we know the state variable, then we can find the state equation. Okay. Suppose they given in S domain means we have taken the inverse Laplace transform, then we have to go. Suppose for example, if it is present in S domain, okay, if it is S domain means then we have to take Laplace transform d cube by dt cube, nothing but s cube into y of s. So if you know the Laplace, inverse Laplace transform for s cube y of s, then we can convert into d cube by dt cube. Suppose if they given in s square y of s means, then we take inverse, it can become d square by dt square. Similarly, we can have du by dt and y of t. But in this question, we have directly we have in the time domain in the form of highest degree of 3. Okay, since the degree is highest degree is 3, highest degree is 3, so we can form 3 state variables. We can form 3 state variables. Okay, so the 3 state variables can be formed by x1, x2, and x3. x1 nothing but lowest order variable, that is we can take y as the first state variable, and next state variable can take du by dt as the second state variable, and x3 can be formed as the d square y by dt square. So these are the 3 state variables. So x1, x2, x3. For state equation, we need x star. So we have to form the derivative of x1, x2, and x3. So what is the x1 dot? X1 dot nothing but derivative of x1. So form x1 dot nothing but what? One derivative of y nothing but du by dt. This du by dt can be formed as x2. So we can write as a x2. So this is the first equation, derivative of x1 dot. Similarly, x2 dot nothing but what? First one derivative of du by dt, nothing but d square y by dt square, nothing but x2 dot nothing but what? D square by dt square, nothing but x3. So we can write x3. So make this as equation. Okay. So only x3 dot nothing but d cube by dt. So here we don't have d cube by dt cube in this state variable, but in the question itself we have in d cube by dt cube. So from here, okay, what is the d cube by dt cube? D cube by dt cube nothing but make it to right hand side equal to, so minus 6 into d square by dt square, nothing but what? x3, minus 6 into x3 minus of 11 into du by dt. So minus 11 into du by dt nothing but x2, 11 into x2. Okay. Similarly, minus 6 into y. So minus 6 into y nothing but x1. Okay. Minus 6 into x1 and minus of u. So this is equation 3. So we got x1 dot, x2 dot, and x3 dot. Okay. So from this form, matrix of x dot nothing but x1 dot, x2 dot, and x3 dot. Okay. So A matrix is, since 3 state variable, we can form 3 cross 3 matrix. So into what are the variables? x1, x2, x3. So this is A matrix we are going to form, and B is 3 cross 1 Ax plus b into u. Okay. So now see the first equation, x1 dot equal to x2. Only the coefficient we having x2. So x1 coefficient is 0, x2 coefficient we having 1, x3 coefficient is 0. There is no u. Okay. So u also put it as a 0. Similarly x2 dot, the x2 dot we having x3, only x3, put 0, 0, x3 coefficient alone put 1. There is no u also put it as a 0. Okay. Similarly for x3 dot we having x1 coefficient, see the x1 coefficient minus 6, x2 coefficient is minus 11, x3 coefficient is minus 6. Okay. And u is we having minus 1. Okay. So we got the state equation. So this is the state equation, equation number 4. So this is the state equation. Okay. So this is a A matrix and this is B matrix for this state equation. Okay. So this is the first step. Next, you are going to find the output equation. In how to find the output equation? Output equation represented by y equal to c into x. Y equal to c into x. Okay. And see this equation. Is there any y equation? So in the first equation itself we having x1 equal to y. So y is taken as the output. Okay. So the y can be represented c into x. So y can be represented, c is a 1 cross 3. 1 cross 3 matrix into state variable x1, x2 and x3. Okay. So see the y equation corresponding what is the coefficient of corresponding variable. So only we have x1 coefficient is 1. There is no x2 coefficient, there is no x3 coefficient. So this is the output equation. That will be equation number 5. So this is the output equation. So both fourth equation and fifth equation forms the state model. That is the state equation plus output equation forms the state model of the given differential equation. So from this, so we have seen, so the given differential equation, take inverse take this how many number of degrees present. Okay, from that number of state variable form it, corresponding state variable form it. Okay, from the derivative, take the derivative and first of all find the state equation, then find the output equation. Okay, I think this is understand for you. So next class you will see one more problem. Thank you. Good morning, students. Today we are going to see how to obtain the state model for the given mechanical system. So here they give mechanical translate system they given with the two masses. Okay, with the applied force F to the mass 1. Okay, and we have the dashpot V1, V2, and we have two springs K1, K2 present. Okay, so what is the state model? State model nothing but x dot equal to ax plus bu and output equation represent y equal to cx plus u. Previously you have seen how can you find from the differential equation. Now we will see how to obtain the state model for the given mechanical system. For that we have to write what is the force balance equation for both the masses. Okay, we will start with the first mass. For mass 1, so what is the applied force? What are the opposing force? By Newton's second law, the applied force is F of t. Okay, what are the opposing force? We have the opposing force for the mass 1, so that can be represented by Fm1. Okay, similarly we having what are the other element connected to the mass 1, K1 and B1. So we can write Fk1 plus Fb1. Okay, so what are the corresponding equation for mass, spring and dashpot? So we know what is F of t equal to, for mass nothing but m1 into d square, corresponding displacement is y1. So d square y1 by dt square. So k1 is common to both displacement y1 and y2. So normally we can write k1 into y. So here we can write k1 into y1 minus y, since it is acting on both the displacement. For d1 we can write d into dx dy by dt. But this is acting on both the displacement. Here we are considering for mass 1. So b1 into d by dt of y1 minus of y. Okay, so it's a differential equation for the mass 1. Okay, so here, so this is the equation 1. Similarly for the mass 2, mass 2 m2, so there is no applied force in the mass 2. So, but we have the opposing force, just add all the opposing force and equal to 0. Okay. So, what are the opposing force? Fm2 is will be there, and acting on the mass to alone we have the force is there. Fp2 plus Fk2. The other force acting on B1 and K1, Fb1 plus Fk1 equal to 0. Okay, just write what is the corresponding force balance equation. M2 is M2 into the displacement acting here is Y2, so d square Y2 by dt square plus B2. So B2 is acting on the Y2 displacement, so B2 into dy2 by dt plus K2 into Y2. So here B1. Here B1 acting on both the displacement, we are considering for second mass. So B1 into dy dt into Y2 minus of Y1. Okay, plus K1 acting on both the displacement, but here we are writing K1 into Y2 minus of Y1. Okay, equal to 0. So this is the second equation. So we got two differential equations. Now we have to convert this differential equation into state one. Okay, that is state equation as well as output equation. For that, we need to take this differential equation. We have two differential equations. So we will see the highest degree. We having highest degree is 2. Here also highest degree 2. For each equation, we have to form state variable. Highest degree is 2 means we have to take two state variable here. We have to take two state variable here. So totally we having 4 state variable. Okay. The 4 state variable can be formed from the lowest order. So here the lowest order we can form like this. Just to multiply both the equation. So you can have d square by dt square, and we have the dy by dt as well as dy2 by dt. Okay. So we can form 4 state variable. We can form like this: x1 equal to y1, and x2 equal to y2, and x3 equal to. So these are the two lowest order for both the equation. The next order nothing but dy by dt. So here you can next order is dy by dt, and that will be x4 is the dy2 by dt. So we can form the 4 state variable from the degree. And what are the state variable can be formed from the lowest order? So y1, y2, dy by dt, dy2 by dt. So these are the 4 state variable. So for this you have to find the corresponding derivative. X1 dot we have to find. So from this you can find the A matrix as well as B matrix. Okay. So now you can form the so here the F represents the input for this mass. Okay. So from the equation 1, okay, so we have to form x1 dot. So how can you find x1 dot nothing but dy1 dt. So dy1 dt nothing but x3. So form the x1 dot nothing but dy1 dt, nothing but dy1 nothing but x3. So make this as equation as 3. Okay. Next x2 dot nothing but x2 is y2, x2 dot dy by dt, dy2 by dt, nothing but x4. Make this as equation 4. So we got 3 and 4 easily. But x3 dot nothing but x3 is dy by dt, d square y1 by dt square. D square y1 by dt square where is present only in the equation 1. From this you have to find the x3 dot. Okay, so first of all find what is the d square y by dt square from this equation. From the equation 1, okay, m1 d square y1 by dt square equal to f of t. You can write, make this other equation on the right side. Okay, f of t minus of, so makes it k1 by m1. So we are going to divide the m1 by all the equation, k1 by m1 into y1 minus y2, okay, plus minus of d1 by m1, okay, d by dt of y1 minus y2. So this equation is going to form x3 dot. Okay, so x3 dot nothing but dy by dt square. So we can write here this is x3 dot equal to f of t is input, right, as it is f of t minus k1 by m1 is constant, okay, into y1 minus y2. y1 minus y2 nothing but x1 minus x2. So you can write x1 minus of x2. similarly minus of d1 by m1, okay, dy1 by dt, dy1 by dt nothing but x3, dy2 by dt is x4. So we can write x2 minus, x3 minus of x4. So this is made as equation 5. Similarly, you can form the equation for equation 2. So how can you form the equation 2? So I need x4 dot. I need x4 dot. x4 dot nothing but what? D square y2 by dt square we have to form. So x4 dot equal to, so m2 divide the m2 by making it on the right hand side. Okay. So minus of d2 by m2, dy2 by dt, dy2 by dt means x4. x4 plus k2 by m2, y2 is nothing but x2 plus d1 by m1, dy2 by dt, dy2 by dt is x4, dy by dt x3. So x4 minus x3, okay, plus k1 by m1, y2 minus y1, nothing but x2 minus of x1. Okay, so here all become minus. Okay, since you are moving right hand side, this will all become minus. Okay, so this is equation number 6. So we got x1 dot, x2 dot, x3 dot, x4 dot. Now we can form the matrix. So we can form the matrix y equal to x plus b. X dot equal to, x dot nothing but x1 dot, x2 dot, x3 dot equal to, x4 dot. So we are having 4 variables, x1 dot, x2 dot, x3 dot, x4 dot. So A matrix nothing but 4 cross 4. Okay, 4 cross 4 into x1, x2, x3, x4. Okay, so see the first equation. What is the x1 dot? x1 dot nothing but x3. So there is no x1 coefficient, x2 coefficient, only x3 coefficient. There is no x4 coefficient. Thus B is 4 cross 1 into u. U also there is no u. U is the first equation, there is no u. Okay, f is the u. Okay, f of t is the u. F can be represented as a u. This can be represented as u of t. Okay. See the second equation, x2 dot. x2 dot only we are having x4. So 0, 0, 0, 1, this also 0. x3 dot, see the x3 dot. U is there, okay. U is there. x1 coefficient, see the x1 coefficient. x1 coefficient is minus k1 by m1. Okay, so we got the equation, that is a derivative of the equation. How to form the state equation? So here state equation can be formed by x dot equal to ax plus bu. Okay, so you are having 4 state variables, x1 dot, x2 dot, x3 dot, x4 dot. Okay, so from the x1 dot, see the what is the corresponding variable? We have x3. So we can write x1 coefficient is 0, x2 coefficient 0, x4 is 0, x1 only we having. Similarly, u coefficient is 0. Okay, there is no input variable. Okay, similarly for the next x2 dot we are having only x4 coefficient. So there is no x1, x2, x3, only x4. There is no input term u. Okay. Similarly, x3 dot we are having input term. See the x1, x2. Okay, x1 we are having minus k1 by m1. So we are having minus k1 by m1. Okay. And we are having x2 coefficient plus k1 by m1. K1 by m1. Okay. x2 is, x3 is minus b1 by m1. Minus b1 by m1. And x4 is b1 by m1. So b1 by m1. Okay. And u term we are having f of t is nothing but u. Make it as a 1. Okay. So for x4 dot we are having x1 coefficient. See the x1 coefficient wherever present. We are having x1 coefficient minus k1 by m1 into minus x1. So minus will be getting positive k1 by m1. Okay. x2 coefficient present here as well as here. So minus k2 by m2 minus k1 by m1. Okay. So minus if we take outside. So minus of k1 plus k2 by is M1. X2 coefficient is minus K2 by M2 plus K1 by M1. Okay. So X3 coefficient. See the X3 coefficient present on here, minus of B1 by M1. So plus B1 by M1. Okay. X4 is having present on this term as well as this term. We have minus common. If we take minus common, okay, minus we take common, B2 by M2 plus B1 by M1. Okay, but there is no U term, there is no F term, so make it as 0. Okay, so finally we have tried the output equation. So this will form the state equation. This will form the state equation. So for the output equation, we need to check the x1, x2. So since the y1, y2 is taken as an output, so we have two equations. That is a y1 equation separately, y2 separately. So we have to form 2 cross 4. 2 cross 4 we have to form. Okay. So what is the first equation? y1, y2. So y1 we are having x1. So 1, 0, 0, 0. And y2 we are having x2, 0, 1, 0, 0. So 2 cross 4 matrix into x1, x2, x3, x4. So this equation forms the output equation. Y equal to, so this is C. For the state equation, this 4 cross matrix is a and this 4 cross 1 is a B matrix. So this is how we are obtaining the state model from the mechanical system. Thank you.